Good morning, everybody. Thanks for being here. We get a little late start, so everyone can filter in. So we're happy to see you. I'm Prismatic. I'm Preston from Prismatic Labs, one of the founders of the organization. We're an independent team. Let's see how to use this. We're at least 6 people. I think we're 12 now. I can fit everyone on this slide. We've got hundreds of open source contributors. We're really focused on trying to make Ethereum scale. And that is through proof of stake and sharding. And what I want to talk to you guys about today is, what does it mean to scale Ethereum and why are we doing it? What are some obvious ways that we could scale and why are those not good ideas? And we'll dive a little bit into exactly how it works. So we're going to start with just reading all the code. So I hope you guys had coffee because we're going to read line by line all this messy Python. And not really. So let's just move on to the fun stuff. So this is actually going to be a pretty low tech talk. It's not going to go into the code. I'm sure you guys would be relieved. And then here I'm going to shock you with some slides here in a minute that kind of show how complex this system really is. But what is it? What is Ethereum exactly? Well, it's this idea that we can have a decentralized world computer. We can run applications all around the world where we have this immutable blockchain. It's open source. It's thousands of machines. It's everything. And there's lots of use cases, right? The most common ones today being like DAOs, ERC tokens. Anyone can create a token or currency. dApps and things like NFTs are really popular. So yeah, talking about the complexity of this, this diagram is kind of visualization of what how Ethereum works. And I don't really want to go into all of it because it's a lot, but I want to focus on basically two parts of this. So the first one being down here, proof of work. Proof of work is this really simple, elegant solution where we can hash all of the information that we want to prove with a random number, and if this random number that comes out has basically a hash collision, so meets this like difficulty, then we've considered, we've done enough work to prove this. It's really hard to do, but really easy to prove. So it works really well. But the problem is that it's really energy inefficient. So we're going to talk about that. And we're going to talk about blocks. So over here we have a block. There's a ton of stuff that goes in a block. We're mostly going to care about transactions and how we can fit more of them into blocks and go faster. So let's dive right into it. What does it mean to scale, and why are gas fees so high? When I made this slide, gas fees were really high, and now they're like not that high, which is kind of cool. But let's pretend we're still talking like 200 GUI minimum transaction fees, stuff like that. When you look at the big picture, right, there's a lot of things that act as currency, right? So we have Bitcoin, which can do, in theory, about 7 transactions per second. Ethereum can do 27. Visa, some payment processors, centralized payment processors, can do a lot. They could do, 24,000. I think they argue they could do more. Probably on average, it's a lot less. These numbers are kind of old, but it just goes to show that, these two on the right, they made a lot of trade-offs so where we don't sacrifice centralization, but we have a problem with scaling. And Visa doesn't have that because they control everything. They can go fast. The other part of it has to do with block times, right? So when I submit a transaction, what is the typical minimum time that I can get my transaction included? In Bitcoin, it takes 10 minutes for a block to be produced. In Ethereum, it's about 14 seconds. And Visa, I don't know, I couldn't really figure this out. Like when you're at the grocery store and you do a transaction, it takes like 4 seconds or whatever. But actual settlement takes like 2 days, right? So, that's still not great. They're making trade-offs as well. But from the user perspective, Visa's the winner here because when you're at the store doing it, it doesn't feel like that long. And that's what Ethereum needs, ideally could be, is it doesn't need to feel that long to get your transaction in. So how do these fit? How do we fit transactions into blocks? Basically, a block has a limit, and it's called gas. Gas is a unit of work that a transaction does. So the most simplest one being, I'm sending you money and you're receiving it. The money being Ethereum's native currency, Ether. That's the minimum transaction fee is 2,100 gas. And a block has a limit of how much gas in it. And this limit can move up and down. It does from time to time. But in general, it moves very slightly unless it's like an organized kind of upgrade to Ethereum. Miners, the block producers, they receive parts of this rewards as rewards, the gas. Now we have, it's a little bit different now with EIP 15 to 59. This protocol upgrade that was done last year where most of the fees are burned into oblivion or destroyed, and only the tips, the fee, go to the block producer. And this is just a diagram showing you in the first couple of years of Ethereum how the block limit or gas limit has changed. In general, you have these like little tiny blips, or even really hard to see. Maybe more notable over here, it changes a little bit. The miners can vote on it from time to time based on capacity, but then they can also vote on these really big jumps where it's more of an unorganized effort to increase the gas limit. So that's cool. We know how transactions fit into blocks. How do we do more of them? How do we go fast? How do we get Ethereum to be from that loaf of bread to this race car? Well, we have to think about the properties of Ethereum that we really care about. Most importantly, being decentralization and security. These are like the pillars of Ethereum. But you also want scalability. You want to go fast. And it's really easy to give up something here for something else. So we could give up some security, go faster. We could give up decentralization, go faster. We can do a lot of things, but it's really hard to get this right and kind of keep this triangle, balanced. So we call it the scalability blockchain trilemma. One obvious thing you might have thought is that, okay, well, if we can fit so many transactions in a block, the block comes every 14 seconds. Why don't we just put more transactions in there, increase the block limit? That's one way to scale. Well, the problem with that is that everyone's running, well, not everyone, but a lot of people are running Ethereum nodes today, and they're running it on consumer-grade hardware. And if we start to increase the computing requirements for this, it's going to start pricing out people just in the hardware alone. So with that, it's an obvious thing to do, but really, we're giving up something there. We're giving up that decentralization part of it. Another thing is just do blocks faster, right? Why are we waiting 14 seconds? We could do it faster. But with proof of work, doing it faster means lowering the difficulty. And if it's easier to do, you're giving up some of your security budget. We kind of gave up a little bit of that triangle, then again, to go faster. It also has other issues where blocks coming in a lot faster mean that there's a lot more forking. It may be a less desirable user experience. You could see large reorganizations of the chain. It makes it more vulnerable to griefing attacks, to all kinds of different scenarios. And then when you're thinking about I want to deposit my ETH on Coinbase, and they make you wait 25 blocks. Well, they may make you wait even longer because of these reorganizations are more likely. So it's a good idea, but it's giving away something here, a bit of security, and it's taking away from taking away from some of the user experience. So we're not going to do that. But what can we do, right? So in general now, there's kind of two layers of Ethereum we're thinking about. There's a layer one that everyone's familiar with. It's mainnet Ethereum, where all the dApps are living for the most part. And you can scale there, right? So if we can make these improvements on the root layer, the protocol layer, the layer one, everyone benefits. It's a little bit harder to do versus something like layer two, where you can start fresh. You don't have to consider that there's already this running blockchain in operation, and you have to do it without breaking anybody. You can start from greenfield. It could be a little bit easier. Could also be a little bit more flexible. You can make a layer 2 for anything. You know, if you wanted one for your CryptoKitties trading platform, or like DYDX, like something like that, you can do it. You know, that's anyone can do a layer 2. And if you do it correctly, you like with rollups or these other technologies, it doesn't really give up a whole lot, but in some cases, it really depends on how you do it. So some layer 2s may not be as secure or decentralized, especially when there's a centralized operator that sequences or sequencer that handles all transactions. Okay, so let's talk about what we're doing about Ethereum 2.0. This is originally a really big idea that we always knew that would take multiple years. Vitalik's quote is here. It's a big multi-year long upgrade, massively increase blockchain through proof of stake, sharding, programmability, all this kind of stuff. Like, there's a lot we wanted to do. And you can read it. I won't read it all to you, but we have this really big vision with Ethereum 2. And it starts with the beacon chain. It's kind of hard to see, but we got a lighthouse here with a beacon of light coming out, symbolizing the beacon chain. It does a lot, right? And I told you this wouldn't be too technical, so I'm just going to kind of go over the highlights of this. The beacon chain is the proof of stake implementation for Ethereum. It handles all the registries, all the balances of validators. It handles rewards and penalties, shuffling and randomness, and finalization. So one cool thing about proof of stake versus proof of work, we can have these finalized, that we all agree, finalized segments of the blockchain that can't be reorged. So in proof of work, you can go back to a prior block and start mining on top of that one and try to mine faster than everybody else. And in proof of work, basically the longest chain wins. Well, in proof of stake, you can't go back any farther than the last finalized block. So it mitigates that quite a bit. And then eventually, well, very soon, we're going to be merging this technology with Ethereum and removing proof of work. It's really, yeah, exactly. It's really about the sustainability, right? Proof of work is energy intensive. It's a bit wasteful, you know. These computers, this electricity, energy could be used for something else. Even if it is clean energy, you know, it's better used somewhere else, most likely. This graph shows the probable CO2 emissions in megatons per year of Ethereum, and this chart just makes me sick. Like, to be involved in something like this is just producing so much CO2. It's just something that we could do better, and we're going to do better. And it's just a nicer way to go about with this technology, which will really help drive, you know, global mass adoption. We can't get there with this chart, which will only get worse. Everyone will see it, and it's something we got to do. Take a look at the roadmap. We started this in, well, proof of stake and switch to proof of stake has kind of always been on the roadmap for Ethereum since the beginning. And this is only looking at 2020 and beyond. But we launched the beacon chain in October 14, 2020. That's when the deposit contract was published on the chain, and we could start receiving deposits. And then on December 1st, the beacon chain actually launched. And when that happened, we have still the proof of work Ethereum mainnet, the Ethereum that everyone uses, with the proof of stake beacon chain running alongside. The idea here was that we could get proof of stake bootstrapped, we could get things working, we could test an upgrade. We were able to do an upgrade called Altair, which has got a lot of light client support functionality. And meanwhile, the proof of work chain, the Ethereum mainnet that everyone's using, was mostly unaffected by these upgrades, so they can continue doing their own. And then in 2020, we're working on more testnets for the merge, switching to proof of stake. We just launched the, we think the final like private, semi-private, semi-public testnet Kiln and that was a success on the merge. And the next steps are to start upgrading these other well-known testnets like READB or Goerli or other ones to get even more data and confidence in the merge event. With that said, there's still several more months to go. It's hard to say exactly when the merge will happen. A lot of people ask when merge. I don't know, but soon. This year for sure. It'll be soon. It's happening, so get ready. The merge is the real ETH killer. It's the ETH2 killer. We no longer, well, most of us no longer call it ETH2 anymore. It's just Ethereum. There's a few like diehard guys left that still call it ETH2, but I'm gonna officially say here that I'm not gonna say it anymore. It's gone. It's dead. It's just Ethereum after the merge, so that's great. I guess I'm not too happy about it, but we're gonna do it. Okay, so then what, right? The merge. Okay, what about scaling, right? That's what we're talking about. That was just the proof of stake part, which didn't really help with our transaction capacity. It really helped with our environmental impact and bringing the rails for the next steps. We've got a really long roadmap out there, multi-years, multi-stages, all kinds of stuff to do. We think that the Ethereum layer 1 will mostly be a settlement layer, and the real scaling, the go fast scaling is going to come through layer 2, most likely through some form of roll-up transactions where you have all this activity on a layer 2, it's all rolled up into one bundle, and then that is committed to layer 1. So you share the fees with your fellow users on that layer 2, and the fees would therefore be much smaller. That's already happening today. We've got really cool networks like Optimism, Arbitrum, Polygon, Rollup Chain. Lots of cool stuff happening today. That's already happening in parallel. Something next we want to do is bring in data sharding. So those layer 2 need to write to the blockchain. They need to write to the layer 1, and we want to give them a much better space to do that. Right now, they're just writing into smart contracts and then sharing those fees with other smart contracts, and they're not really doing, for the most part, not really doing any EVM execution. They're really kind of writing these proof commitments. Well, what we could do is have the data sharding where there's a plentiful space for these things to be written, and then the layer 2 fees will be much smaller. So when we get through that, we call phase 1 of what the beacon chain was phase 0, so that might be a little confusing. But the next phase 1, that's the sharding part where we're introducing the data layer for layer 2. Then beyond that, we're still thinking about, we had this vision of sharding where we have multiple Ethereum blockchains that are running in parallel and all somewhat connected with their own execution environments. And so they would have different fee markets and all this kind of stuff. But the vision is not totally clear, and the research is suggesting that maybe we stick with a layer 2 future where we add in a few more things and kind of think that Ethereum should be the settlement layer, then layer 2s have a lot of the application layer. Beyond that, we still have other problems to solve. So Ethereum's state, Ethereum's disk resource usage is growing every day. I think there were estimates that's like 2 gigabytes a day. Maybe it's not that much, but it's getting to the point that if we don't do something about it, it's going to exceed the rate that hardware is improving. Right, storage is getting cheaper every week, every day, but the Ethereum state is growing faster than that. So we want to do things like supporting stateless clients, light clients. So that improves a bit of decentralization. You don't need to connect to some provider like Infura or whoever to get access to Ethereum. You can just do it from your phone, perhaps. And then cleaning up the state with state expiry. So getting rid of old data that's no longer used. Those will be really big for Ethereum. And yeah, just to recap this quickly, the thing formerly known as Ethereum 2.0 It's proof of stake and blockchain sharding, and sharding can mean multiple things. We think it's either going to be just sharding data to have more data in parallel, or actual execution environments in parallel. This is pretty much a entirely new blockchain. You saw in the roadmap that the beacon chain is running separately, and then they'll merge together. It's not just a normal hard fork where everyone upgrades. It's actually really different. It inherits all the properties of the old blockchain, but I like to think of it as a brand new invention, a brand new thing. And that's why it was called 2.0. But after the merge, it's no longer 2.0. We're just Ethereum. So that's great. And the future, again, is layer 1 is mostly settlement layer, and layer 2 is going to be really where the applications live and run and go fast. And cool, that's it. I'm from Prismatic Labs. We're hiring, so if you guys want to work on the core infrastructure, protocol layer stuff, reach out to me. This is our group Twitter, and I'll be hanging around. So I'm even next to talking to Evan, so we'll be chatting some more. And I don't know what we're on time, but we might have time for questions. So if anyone, okay, let's just do it. If anyone has a question, go ahead and holler it out. We'll answer it. Yep.
So with the switch from proof of work to proof of stake, do the miners now, like, let's say I'm a miner, right? I'm not. Do I switch to becoming like a validator or something? Like, what does that look like? And are they like happy about it?
Yeah. Two good questions. What is it like to go from a proof of work miner to a proof of stake? Is it going to be an easy switch? So it's a really different paradigm, right? Before you needed all this specialized hardware, graphics cards, all these kind of things. Now instead of having a hardware capital requirement, you actually need to stake actual capital. So that being Ether, to run it all yourself, to do it yourself, you need 32 ETH. That's the minimum to run one validator. There are solutions out there where you can pool this together with others. Rocket Pool is a good example. So you may not need all 32 ETH to do that. You can sell all your hardware, recoup some of those costs, and run it on much cheaper machines. I run my validator on a Raspberry Pi 4, 8 gigabyte RAM. It's super small. It uses basically zero energy. It rocks. It's awesome. And then remind me your second question. Are they happy about it? Yeah. I don't know. I don't know if they're happy about it. Some of them are not happy about it. Obviously, we're taking away this opportunity they've had for a long time. But we also, a lot of us argued that we've been overpaying for the security budget and basically giving away money to these guys who are, they are providing value and providing service for Ethereum, but it's too much. So some of them are not happy. Some are a little upset about it, but we think that it's not going to be as contentious as it could be. I think it'll be a pretty smooth upgrade. Yep. Yep.
I'm wondering, is there like a world in which you decouple further the data availability and the execution portion, something like what Celestia is kind of angling for, where maybe that doesn't need to be bundled so tightly, and that kind of allows further efficiency gains?
Okay, question is, can we decouple data availability and execution further, like Celestia does? I'll admit that I don't know much about their research or their implementation. I want to say that if it's possible and there's a real value from it, that it's worthwhile to investigate and to research. From what I know, I'm not aware of any specific plans that have been started on that. We still have quite a bit on the roadmap to go this year and next year before we're kind of in the state that's what makes sense for Ethereum. But I'm actually going to look at it later today and see if that's something that really needs to be done, because I want to know more about it. Thanks for that question.
Yep. Can you maybe dive in a little deeper into like the transition to Ethereum 2.0? And what I'm asking about that is like the risks that might come up as part of that transition, or I guess as you move into the sharding proof of stake, is there any inherent risk that we should be thinking about? I guess.
Okay, so the question is like how exactly we might do this merge and like what are the risks with that?
Yeah.
Yeah.
Is there's any risk to the protocol as part of the
Yeah. So the way we'll do this merge is Ethereum's difficulty for proof of work is always increasing. There's always new graphics cards, people coming online mining Ethereum. The way the merge will work is we'll say when a certain point in time has happened on the beacon chain and the total difficulty has reached this certain threshold, that's going to be the last block that is mined, and we're then going to switch over to proof of stake. So the risk with that is that maybe it doesn't happen in the order we expect. Maybe that point in time hasn't happened yet, but the total difficulty happens. And what you could see is that, and this is I guess the worst case, is that all block production stops until that point in time. Hopefully it's not going to happen because, when the way we can estimate was say, we'll put this difficulty high where we think it'll take a month to get there and then set the point in time to 2 weeks. So we have maybe a 2-week buffer. And then of course, if it happens like crazy early, I mean, we could do something about it. We could do another upgrade or just wait. I don't know. But that's the risk that I see with the merge is that it could stall. But if we do the calculations and projections right, it shouldn't stall. In the back, question.
Are there any solutions for being able to stake or be involved in Ethereum if you don't have access to pools or having enough funds to actually get involved in staking?
The question is there any solutions to participate in proof of stake without having enough capital to be a full validator and without being in a pool? Short answer, I don't think so. I don't think it's possible. In the protocol, a validator has to have 32 ETH to join. And the only solution away around that, if you don't have 32 ETH, is to pool with someone else. And either that's through an organization like Rocket Pool or something else, or you actually do it socially, you team up with your friend or your brother or whoever and pool your own resources and operate a validator. There's really no way to do any delegated proof of stake or fractional validators or anything like that. Yep, in the back.
So you were saying earlier that if you change the block time or block sizes, that would affect the database size, and it would grow at a rate which faster than the technology was keeping up with. Don't you see a similarity with that with the proof of stake and the ETH required proof of stake? When you guys started ETH2 launch, it was like $10,000. We saw it hit $160,000 this year to create a validator.
Yeah.
Don't you see that as a problem too? Needing everyone to be able to participate in the staking?
Yeah. So the question is, is it a problem that the price of Ether is increasing and that is increasing the barrier to entry for a solo validator? Absolutely. When we were memeing around in the beginning of this and saying, now it's $10,000 to do a validator, and then the price would drop. Say, look, it's only $5,000, and we were like, at the time, like that's still a lot of money, but a reasonable amount. And then when it goes over $100,000, like who's going to do this besides the whales and the institutions? I'm a little concerned about it, and I think that if these like moon astronauts get their way and ETH goes to the moon, then we're going to have an even bigger problem. A lot of people will be happy about that, about the price of ETH going up, but this is still a concern for decentralization. I believe that we could do something at the protocol layer if it's agreed upon that we could maybe split up validators or reduce the requirement significantly to allow more people to enter without giving up too much of the security budget. Because we didn't think we needed a $100,000 security budget per validator. We thought we needed like 10,000. So it can be adjusted. Ethereum is great in the way that it could be upgraded and reconfigured over time. You guys right here.
Do you know where we stand, or where do we plan to see allowing withdrawals from the 2.0 contract since the 32 is currently locked?
Yep.
For I don't know how long.
Okay.
And once that is unlocked, do you think that will cause problems with a lot of people unlocking and reducing the number of validators?
Okay, so when withdraws, that's going to be the next thing after merge. Like that's on the roadmap. in the internal groups with the research, most of us agree that we need to deliver on that promise of being able to withdraw, especially partial withdrawals. So I don't think that we'll see a mass exodus of people that are saying, finally, I can have my money back. What we'll see is people saying, wow, I have earned 3 ETH and I've been running 10 of these. I have enough to start an 11th one. So I'm going to take all those earnings and put them back into Ethereum. I think we'll see that way more than we'll see people exiting. So I think it'll be good. And that's important to us to get it done soon. So
you mentioned right there where the red line ends. That
Yeah.
moment has 2 dynamic variables. At the moment it has difficulty.
Yeah.
And it has like a maximum epoch or something.
yes, a minimum epoch.
A minimum epoch.
Yeah.
Why is that's 2 different flexible variables? Because from my understanding from the launch of proof of stake, it was like a single epoch or something that was everyone could have a launch party that was
Yep.
at an exact time.
Yep. Okay, so why are we using total difficulty for here and a minimum epoch? Well, the short answer is that if we just said a block number and say, okay, at block number 15 million and this epoch, we're going to do a merge. The problem with that is that some rogue miner could go privately mine a little chain over here and then collude with the first validator that's supposed to do that, and then all of a sudden publish all those blocks and then be the first one to be there. And that could be a pretty big reorg. It could be really annoying. So one way around it is we say, all right, well, when it's reached this total difficulty, which you can't really, I mean, I guess you could do that private, but it's still like really hard to do. Yeah, the scenario is that when you do it privately, you could do it for like a really low difficulty. All you had to do is reach that block number. Here you have to do really hard work, and it's going to be hard to outpace everyone else to do that for little gain. So that's really the reason is to prevent that that kind of attack. Yep. Yep. Okay. All right. Last question. Sorry. Yep. It's a power of 2. It's just a nice number that we like. I mean, that's really it. It seemed like a good amount of value, and it is a power of 2, which makes things simple for programmers. So that's really it. Yeah. All right. Thank you, guys.